Hello everybody, welcome to today's lesson. In today's lesson we'll discuss types of sets. The lesson is divided into 3 parts. In the first part we'll talk about the empty set, a unit set, finite set, infinite set. Part 2 will be subset and superset. And in the third part we'll talk about the universal set, equal sets, equivalent set, disjoint set, and the power set. Before we begin, if you are new to this channel or you've not subscribed yet to the channel, please subscribe and don't forget to hit the notification bell to be notified when we post new videos. Are you ready? Let's get started. The names of these sets we're about to discuss give us an idea of what the sets are. To begin, let's talk about the empty set. The empty set. This set is also called the null set or a void set. Now let me ask you this. What do you think is an empty set? I'm sure you got it right. An empty set or a null set or a void set is a set that has no element in it. And to represent an empty set, we use either of these two symbols. So let's imagine a set A is an empty set. We'll say A is this. You remember we said we put the elements in a set in curly bracket. So set A has nothing in it. Or we can also write set A as this. Then we'll see it is an empty set. So either of these is fine. But can there really be a set with no element? Yes, of course, there can. Let's think of this set. A set of multiples of 4, which are also prime numbers. Is there any prime number that is divisible by 4? No. So if we want to call that set set K, the set of prime numbers divisible by 4, then definitely it is going to be an empty set. So again, an empty set is a set that has no element in it. Let's move on to the next type of set, the unit set. A unit set, or what is also called a singleton set, is a set that has exactly one element in it. So it has exactly one element in it. For instance, let us consider set P. Set P has an element in it, and the element is the number 5. But how many elements are in set P? Set P has just one element, the number 5. So we say that set P is a unit set. It has just one element. Let us consider set Q. Set Q has how many elements? How many elements does set Q have? Set Q has just one element, and the element is 0. Please take note that set Q here is not an empty set. It has an element, and the element is 0. Let's consider another set, set R. Set R has 123 as an element in it. Is set R also a unit set? Yes, it has just one element in it, the number 123. And finally, let us consider another set, set T. Set T is 1000. And of course, it also has just one element, the number 1000. All these sets I've written here are all unit set or singleton set. Let's move on to the next type of set, the finite set. We're now going to talk about the finite set. A finite set is a set whose element we can actually finish counting. So if the elements of a finite set are listed and we have to count them, no matter how many they are, we can actually count them and eventually finish counting them. In other words, we can say that a finite set is a set that has a definite or an exact number of elements in it. So for instance, a set which has, say, 10 number of elements, a set which has 1,000 number of elements, a set which has 1 million number of elements. Since we know the exact number of elements in that set, we say the set is a finite set. The null set is also a finite set. Why do we say that? Because it also has a definite or an exact number of elements. And how many elements does the null set have? I'm sure you got it right. 0. And that is an exact number. So the null set is also a finite set, and all other sets that we can actually count to the end are finite sets. Let's write down a few examples of finite set. So let's consider set A. Set A has these elements: -1, 0, 1, 2, and 3. Set A starts from -1 and it ends at 3. We can actually count the elements in set A. How many elements does it have? It has 5 elements in it. Counting, we'll see that set A has 1, 2, 3, 4, and 5 elements in it. Consider another set, set B. Set B has these elements: 2, 4, 6, 8, 10. Let's put an ellipsis there to show that there are other numbers there, and then we'll end at 16. This break is telling us that there are some numbers there, this ellipsis here, but then the set also has an end. So how do we find the numbers here? All that we do is that we check the pattern that the first few numbers follow, and of course they follow a particular pattern. They just increase by 2. We keep on adding 2 to them. So easily we can even identify the next number to be 12, and then the number after 12 will be 14, and then the next number will be 16, and that is where the set ends. So this is also a finite set because we know the number of elements in this set, and the number of elements will be 1, 2, 3, 4, 5, 6, 7, 8. B has 8 number of elements. We have a short video on this channel that explains the number of elements in a set, which is called the cardinality of a set. I will encourage you to watch that video on this channel. Next, I believe you know what we're going to talk about. After talking about the finite set, we move on to the infinite set. Now let's talk about the infinite set. Unlike the finite set, we cannot finish counting the elements in an infinite set. Why? Because an infinite set does not have an exact number of elements. We don't even know the number of elements it has. The elements in an infinite set are so many that when we want to count to finish, we just cannot do that. It is just impossible to count the number of elements in an infinite set. Let's take 2 examples of an infinite set. Let us take set n. And I'm using set n to represent the set of natural numbers. And we know natural numbers, so what is also called counter numbers. They start from 1, 2, and then we keep on counting 3, 4, 5, 6, and we can count on and on and on, and we will never finish. And that is an example of an infinite set. And we put these 3 dots there, and the 3 dots is called an ellipsis to tell us that we can keep on counting in this same pattern and we don't end. Let's consider another infinite set, and I'm going to use the letter W to represent whole numbers. Well, the only difference between whole numbers and natural numbers is 0. We just add 0 to natural numbers and then we have whole numbers. So with whole numbers too, we can keep on counting on and on and on. It doesn't have an end. So we put the ellipses there to show that it is an infinite set. Please don't forget to watch the second part of this video that discusses subset and superset. Thank you.